Hello everyone, welcome to Parthiba Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 8th May 2023. The problem statement for today is binary modulo. Let's now open this problem to solve it. Let's go through and understand the given problem statement. Here it is said, you are given a binary string s and an integer m. You need to return an integer r where r is equal to k modulo m, where k is the binary equivalent of string s. Okay, so the problem statement requires us to convert a binary string s to integer value k and then compute the value of k modulus m. Let's go through the given examples to understand it in a better way. So the first example says the given binary string is 101 and here m is equal to 2. So whatever is the decimal representation we will get with this binary string, we have to do a modulus with this m, value of m. So when we look at this, the binary the decimal representation of this 101, it is equal to 5. And when we do 5 modulo 2, then we get the value as 1. That's why the output here is 1. How we got here this decimal representation of 101 as 5? For that, let me show you here this one. For input string 101, decimal representation we can compute in this way. So whatever is that value, that binary bit value is there, that you need to multiply with 2 to the power that number of bits from counting from the right. So for this last one, the bit position is 0, that's why it is 2 to the power 0. For this 0, the bit position of 1, that's why it is 2 to the power 1. For this 1, the bit position is 2. So that's why it is done 1 into 2 to the power 2. Okay, so this way we calculate the decimal representation. So we get the value of 4 plus 0 plus 1, that is equal to 5. Okay, so that is the 5 here, and when we do a modulus 2 with this 5, then we get the output as 1. When we go to the second example says the string, the given binary string is 1000 and m is equal to 4. So here the output is 0 because the decimal representation of 1000 is 8, and when we perform 8 modulo 4, it will give 0. Okay, so I hope both the problem statement and the given examples are clear. So for solving this problem, what we will do, we will convert the binary string to decimal for each bit and compute modulus m in each step. Okay, so let's understand that how exactly we will do that. So suppose here I've taken the first example only, where s is equal to 101 and m is equal to 2. So initially we have one variable k that is initialized to 0. So what we will be doing, we will be performing this operation. That means k into 2 plus whatever that bit we are getting as the current bit. So this we will be doing in each step. So for the first step, when we are iterating from left to right, so here first we are getting it as 1. So we will substitute that in this. So what is the current value of k? Current value of k is 0. So that's why it is 0 into 2 plus s of I. S of I is here is 1. So that is 1 here. So k we got 1 here. Then we are performing modulus operation in each step. So k is equal to k modulo m, that is 1 modulo 2, that is equal to 1. So this was the first step. When we move to the second step, so now the current bit is 0. So so we will compute the new value of k. So in the previous step the value of k was 1. So it was 1 into 2 plus 0 because the current bit value is 0. So we'll get 2 here. When we again perform modulus operation with m, we get the updated value of k as 0. When we move to the next bit, so the current bit value becomes 1. And in previous step we got the value of k as 0. So 0 into 2 plus current bit value, that is 1, that will give 1. When we perform modulus m with this, we will get the value as 1. So after that the loop terminates, and whatever the value in the k, that will be returned as the result that we will return from this. Okay, so with this logic only we will be solving this problem. So I have prepared the solution. Let me just copy it here. So here I'll just explain what all things we are doing here. So here we initialize integer variable k that is equal to 0. This variable will hold the integer value of the binary string s. Then we use a for loop to iterate over the characters of the binary string s. We have a variable I for that, for the iteration in using the for loop. In the next step inside this loop, we update the value of k. We first shift the bit of k to the left by one position using this binary left shift operator. This is equivalent to multiplying k by 2. We then add the value of the current bit to k. Whatever the value of current bit that we are adding to this operation, or the result whatever we are getting after doing a left shift. Okay, and how we are getting the current bit? We get the value of current bit by subtracting the character code of 0 from the character code of the current character using the minus operator. This will give the value either 0 or 1 depending on the value of the current bit. Then after updating the value of k, we take the modulo with m, that is k is equal to k modulus m. This is equivalent to taking the remainder when k is divided by m. We do this to prevent k from becoming too large and causing an integer overflow. Okay, and after that this for loop is getting closed. Then after processing all the bits of s, we return the final value of k. This value is the integer value of binary string s modulus m. Okay, so here when I explained this, I said this left shift by one bit, this is equivalent to multiplying by 2. Let's understand how is that. So if I take one example here, let me move it. So suppose we have one bit as 1. When we do a left shift, so 1 for this the value is 1. When we do a left shift of it, it will become 1 and 0. Now the value will be 2. When we do a left shift again, it will become 1 0 0. So the value of it is 4. So what we are seeing, whatever the value we are getting, it is getting multiplied by 2 each time. When we do left shift again, it will become 1 0 0 0. See, we are moving one bit to the left. So the current value at the after shifting, the new bit that will be having the value as 0. So it is getting shifted one position to the left. So here it will be 8. So we can see each step the value is getting multiplied by 2. So either we do k left shift by 1 bit or k into 2, both are equivalent. Okay, so I'll show that with this example, and that means that what the result would be after compiling this code. So here we can see we have got correct output with this one. So even if we try doing, instead of k left shift by 1, even if I try doing k into 2, this should also give the same result. So here we can see again we have got the same result. So k left shift by 1 bit or k into 2, both are same. Okay, so with this let me submit the solution. I think some network issue. Let me try submitting it again. It is already in queue. Okay, so here we can see now it has showed the output for all the test cases. So it has covered all the test cases. So here so this was the solution in Java. But before moving to any other part, so here if you can see we are performing this k modulus m inside this for loop. That means after each step we are performing this modulus operation to prevent integer overflow. What will happen if I take this out of this and put it outside this loop? So what exactly it is here? Let me just paste it here. So here if you see, then what we are doing inside this for loop, we are getting the complete decimal representation of the binary string. So here when we look at the first example, So after this for loop, the k will hold 5, and after the second example, k will hold 8, because we are not doing modulus operation inside the for loop. Now if you try using this approach, so this will be fine when the binary string is smaller. But if it is very large, then this might give a problem. So let's try compiling this code. I'll show you that. So this is fine because binary string was small. But when we try submitting the solution, see here we can see in this one, for this input, see this binary string is too large. Okay, it is very big. So if we try converting this entire binary string to decimal representation, then the value of k might overflow the range of integer values. That's why we are doing k modulus m for each step. Okay, so let me just put it back inside this for loop. Okay, so this was a Java solution. So this is working fine. When we move to C++ solution, so let me just copy this here. Actually, the same code is the same logic, same code will work for even for that. Only change will be that we do not have caret function in C++. For that, we use the index-based fetching of data from string. So we have changed that caret to this s of I. So let me try compiling this code in C++. So here we can see, here we have got the correct output for this solution, for this given example. Let me try submitting this solution. So here we can see even with C++ code, it has covered all the test cases. So the approach which we have used in this problem, this is working fine because each bit in the binary string represents a power of 2. And we can accumulate the value of k by shifting it left and adding the value of each bit as we go along. Taking the modulus at each step ensures that the value of k never goes too large. The value of k never gets too large to fit within the range of the integer variable. Okay, for that reason we are doing k modulus m in each step. So when we talk about the time complexity of this solution, this is having the time complexity in the order of big O of n, where n is the length of the input binary string s. This is because the algorithm performs a single iteration over the characters s, and each iteration involves a constant amount of work, that is shifting bits, adding values and taking modulus. Therefore, the total time complexity of the algorithm is proportional to the length of the string. Okay, so here you can see we have solved this problem using both languages, that is C++ and Java. So I'll provide the link for this question and the solution and the link for the solution code in Java and C++ in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.